All right, so the first one, we're going to state the transformations. Now, if it doesn't say in the correct order, I'm not going to grade them on the correct order. But just for the sake of being thorough, I'm going to do them in the correct order so we can practice that. Now, both of these changes are inside. First, we're going to do the negative. That would reflect over the y-axis. And then what does the -7 do? Remember, it's inside, so kind of backwards. Good, right 7. And number 2 says in the correct order. So we do have to get those in the correct order. We're going to start inside. And again, if you want to highlight the inside of the function, you can do that. We're going to start with the 1/3. That would be a horizontal, kind of backwards. Perfect. Nice job. Start by 3. You have to reciprocate it. And then the x plus 5 is left 5. So that's the inside stuff. Now outside, we've got the negative in front. That's reflect x-axis. And then the -8 is down 8. Again, I'm going to provide lines on the test for you to write on, so you'll know how many answers you should have. All right, 3, write an equation. So you should have an f of x equals or a y equals logarithmic function that has the following transformations. All right, so we're going to need, the word log there. We want a horizontal shrink by 1/7. Horizontal means it's going to go where? Inside, so we're going to need some parentheses. And you have to reciprocate that, so it will be 7x. Make sure you put an x, like there has to be a variable in there. All right, reflect over x, that's going to put a negative out front. And then down 9 will be a -9 at the end. So you're kind of just assembling the equation. All right, 4, write the equation of a cube root function. So again, we're going to write an equation. You should have f of x equals, and we're going to need a cube root. So just leave it blank for a second. We'll go and fill it in. We want a horizontal stretch by 6, which means that's going to go inside, and it'll be reciprocated. It'll be a 1/6. And then right 3. Where's that going to go? Inside, good, and it'll be x -3, and you need to give it a hug to keep it separated from the 1/6. I will say that's the most common mistake on questions like that, is that people won't put the parentheses there. So just try to remember to put the parentheses. All right, using the graph to the right, and I think it's written on here that they're red and black. They printed in black and white, so you can't see that. So I do apologize. But this is the parent function, the one that's centered at 0, 0, and then the dotted one is the transformed function. I hope that that's obvious, right? Describe the transformations and then write the equation of the dotted one. All right, so it looks like it went right 2 and then up or down, how much? Down 3. And we're looking at this starting point. If you want to like bold that to compare that, we went right 2, down 3, and then there's a reflection. Which axis did we reflect over? Good, y-axis. And so you're going to take all that information and put it together into an equation. So f of x equals. And actually, you also need to know what parent function this is, because it doesn't say. Good, square root, because you need to know, what to put in your equation. So square root, reflect y-axis. We would need a negative inside. And then right 2 would be x -2 also inside. And again, just give it a hug. And then I have something else. What's the last thing I need to put in there? Yeah, good. The down 3 would be -2. Cool. Thank you for focusing. I know a study guide's not the most interesting thing, but stay with me. All right, using the graph to the right, what is the equation for the transformed exponential function? This is the parent function, is 2 to the x. Right, I would dot in the asymptote, which is at -3. So that means the graph moved down 3. And also, if the original function looks like this is your swoopy thing, what axis did we reflect over? The x. So we're going to need a negative out front. So it'll be f of x equals, we'll need a negative out front of the function, the 2 to the x, and then -3 to move it down 3. Asymptotes are difficult because they're invisible. So just dot them in, just write it on the paper. All right, what is the name for this one? This should be a word. Greatest integer. It looks like an absolute value. I know that happens. It's the double one. So it should be the infinite staircase. All right, transformations. It doesn't say to put them in the correct order, so I'm not grading that. But let's try to put them in the correct order just for the sake of being thorough. What's going to go first? Yeah, good. Vertical stretch by 2. And then up 1. So you're going to start, instead of at the origin, go up 1 and put a point, a filled in point. You're starting with the filled in point, and that's where your first step is. But it's been vertically stretched by 2. So the steps are going to be 2 units apart from each other. So it's like a staircase that would give you a bit more of a workout. Those graphs are cool. I like those. I know they look a little weird, but I like them. All right, number 8. It is a parabola. So what is the parent function called? Good, quadratic. I know that's weird with that vocabulary. Quadratic is the name of the function. The shape is called a parabola. I know that's a little weird. All right, transformations. This is the original one centered at the origin. So how has it been transformed? Good, left 5. And it got stretched vertically. Do you see how it's taller? And I was bolding some of the points so that you could compare them. It's going to be a vertical stretch by how much? Let's see. These points were at 1. Now they're at 5. So vertical stretch by 5. 1 times 5 gives you 5. It's 5 times as tall. Yes, ma'am. I'm going to only give you vertical ones if I'm giving you the graph, because the horizontal ones are too difficult to realize. That is an excellent question. And in fact, I've taught this many years and no one's ever asked me that. If I give you a graph, assume it's vertical, because the horizontal ones, it's way too difficult to even tell. Okay, so assume it's vertical. All right, and I'm going to write the equation. So f of x equals, we need a 5 out front for the vertical stretch by 5. And then for the left 5, it'll be x plus 5. There's lots of 5s in here. And then there's one other thing we need that's missing. Good, the squared, because if you don't have that, it's not a quadratic. All right, and then graphing a line. You had one like this on your quiz. It's y equals mx plus b. So we're going to start at 0, 1. So it moves up 1. And then -3 is your slope. So from that point, you want to go down 3 and right 1. All right, so now we're going to need to transform these point by point, and here's where the order really matters. Again, I apologize. Please bold the point at the top of that semicircle, 3, 3. You also want to consider that point. So let's make a table of these 5 points. So like for our original function. I'm not going to read them all to you because that's annoying, but please just go ahead and write down those 5 points. Right, and again, if you want to use a highlighter to highlight the inside of the function, you can do that. Inside affects x, outside affects y. So when you look at number 10, all of that stuff is inside the function. So what's kind of nice about that is that the y values don't get affected. They're just going to stay the same, which is no work. We like no work. Great. what's going to happen to x? There's two things. It'll be negative, and good, plus 4 because we're moving right forward, opposite. So it'll be negative x plus 4. And then you're just going to do that to all these points. So for 0, you can't negative a 0, just add 4, you would get 4. For 3, you would get 1. For 6, you would get negative 2. For 9, you would get negative 5. And for 11, you would get negative 7. So you're making it opposite and then adding 4. And then all the y values are going to stay the same. So you can just literally copy those over. And 3 of them are 0 anyway, which is nice. And then just plot the points and connect them. And again, I don't want to read all the points to you because I feel like that just gets a little robotic. I'm drawing them up here for you, so you can always look up here. And I know that there's not a real clear-cut way to check your work for these, but if you know the transformations, you can sort of check. There should have been a reflection over the y-axis. Does it look like we reflected it? Like you can kind of check that way and then write 4. Again, I'm going to give you a grid that it fits on. If yours goes off the grid, you had a whoops. So like you done goofed, go back and fix it because I'm not going to give you a grid it won't fit on. All right, so 11 inside affects x. Remember, it's kind of backwards. So since we have that 2 inside there, what are we going to do to the x values? Times 1/2, perfect. So we're going to do half of them. And then what are we going to do to the y values? Add 2, it went up 2. So y plus 2. And if you end up with a decimal, that's okay. We're doing half of these. So for the x values, that'll be 0, 1.5, 3, 4.5, 5.5. And then all the y values you're going to just add 2. And you can also kind of check your math with these because it should look like a semicircle and then like 2 line segments. And if it looks really out of whack, like you didn't get a semicircle, then you know one of the points is kind of off. All right, so again, plot these 0, 2, 1.5, 5. I'm going to stop reading them. And so it should look a little bit taller, like narrower, or like we horizontally squished it. It should look squished in this way and then up 2. All right, I'm not hearing any complaining about that, so I'm going to move on. Here's all the slope stuff. You guys ready? All right, find the slope going through these 2 points. You're going to subtract the y values and then subtract the x values. So the y values first. It'll be 4 minus negative 2, which will be 4 plus 2. Good, the negatives are going to cancel. And then for the x's, it'll be negative 1 minus 3. So that will be 6 over negative 4, so negative 3/2. And that's all I asked you for is find the slope, so that's it. All right, for 13, we're going to have to find the slope. So what we just did in 12, we're going to practice it again. 4 minus 5. And then in the denominator, negative 7 minus negative 3, so plus 3. So that is going to be, oh, Didn't freeze, right? Okay. That is going to be -1 over -4. Negatives cancel, so 1/4. All right, pep talk. It came out to a fraction. It's going to be okay. We can deal with the fractions, yes? We're not going to freak out. Okay. So we need to pick a point to do point slope form. I just always pick the first one. We're going to use this point and this slope. It will be y minus what? 5. Good. Equals what? What comes next? Yeah, the 1/4, the slope. Good. And then parentheses. Good. It'll be minus -3, so +3. That's your point slope. That's the answer for point slope. I think point slope's easier. That's it. That's the answer you've done. Now, rearranging it to get slope intercept is where you work. You have to do work to get that. We're going to distribute the 1/4. So it'll be y minus 5 equals 1/4 x plus 3/4. Please don't overthink that. 3 times a 4th is 3/4. Okay. And then you'll ask us to add over the 5. I know that this is tough. You're like, oh, I have to do 3/4 plus 5. You can't do 5 and 3/4. We don't do mixed fractions, okay? What you want to do is get a common denominator, which would be fourths. So we're gonna add over some fourths. Here's a $1 million question. How many fourths is 5? In other words, what number needs to go there for it to be 5? 20. 20 fourths is 5. 4 times 5 is 20, or 20 divided by 4 gives you 5. Either way you want to think about that. Okay. I did that so that we could have a common denominator, because now when you add them together, this will be y equals 1/4 x plus, you have 3/4 plus 20/4 be 23/4. All right, vertical and horizontal lines. This is your acronym. If we want a 0 slope, that means it's a horizontal line. It will be y equals. So what is the y value for our point? 8? That's it. Ms. Cole, that's the answer? Yeah, that's it. Undefined slope, that's vertical. It would be x equals, and the x part of the point is -6. That's it. Those are the answers. I know they're not much. It says write the equation. It's not much of an equation, but that's it. All right, and then this is the stuff we did last class. Evaluate. We're going to plug -4 in for x. Give it a hug everywhere you plug it in. So -4 squared would be what? Good, 16. These negatives cancel, so it'll be +4, +7, so 27. All right, same thing with 3h. Everywhere that there's an x, you're going to put 3h and just give it a hug. So put parentheses everywhere you plug it in. So when you have a 3h squared, you have to square the 3 and the h. So it will be 9h squared minus 3h plus 7. Don't factor these. That one doesn't anyway. But don't factor them. Just leave them alone. And then this last one is just like on the clue game. We're going to have h minus 2 squared minus h minus 2 plus 7. So it's not about intelligence. It's about organization and being willing to write it down. When you have a squared, you need to write it twice. You do a lot more writing in English and social studies class than you do in here. It's not that much. Pep talk, go team, you can do it. So this is FOIL, first, outside, inside, last, or it's just distributing everything to each other. I'm gonna talk you through it, ready? H times H. H squared, good. Outsides are minus 2h, insides are minus 2h, together, minus 4h. And then -2 times -2 is positive 4. So that's the FOILing part, and then we're going to distribute the negative, so minus h plus 2 plus 7. You get this big long string of terms, and then you combine the like terms together. So it'll be h squared minus 5h plus 13. A little bit easier than the one on the clue game, because the one on the clue game, was there a 3 out front that you then had to distribute? That was a little bit easier. All right, even, odd, or neither. What's the test? What are we going to plug in? Good, negative x, or opposite of x. So everywhere there's an x, you're going to put a negative x. If it comes out the exact same, then what is it? If even, odd is opposite, and if it's like a mixture, then it would be neither. So negative x squared, is that going to turn out positive or negative? Positive, good. So 3x squared, and then this would be negative 4x. Don't write 4 subtract x. I can't give credit for that. Like, I know what you're trying to say, but it doesn't mean the same thing. All right, so even, odd, or neither? Neither. One term is the same and one is opposite. And so same thing with this one, you're going to plug in a negative x, give it a hug. And so again, negative x squared is going to be positive, so 3x squared minus 2. And your conclusion then is what? Even. Don't pack up on me until I'm done. These will be really quick because you have a picture to look at. We're going to state even, odd, or neither. What do you think about A? Is it even or neither? Because I know that's a little tricky. It is neither. It's almost even. If it was centered, you know, it got moved over. Do you guys see what I'm trying to say there? It's hard because it's a picture. It's like, do you see it? If it was centered on the y-axis, it would be even, but because it's moved over, it's neither. All right, how about the second one? Yeah, that's odd. These are supposed to be labeled B and C. The picture's probably moved it out of the way. And then C is neither.